Kirti supported.
Kirti.
I have added Kirti.
Okay, sir.
You can just call her also. I'll just start the meeting. So you can tell her to add. Okay.
Okay, I'll ask her to join.
Good evening, all of you. A meeting after some time, but I have a bad news to share. I mean, it's not a news anymore. We already have, heard about. Most of you would have been in the group. It was informed that Suresh sir is no more. He accidentally, fell from a structure while on inspection, and because he was not wearing helmet, so without the helmet, there was a direct hit of his head on a pedestal, which was inside the tank. So he fell into the tank and, felt unconscious after that. And for a couple of days he was hospitalized, but his memory couldn't come back, and there was brain death. So it's a very tragic news. We lost a friend, a guru, and big brother, we can say. He was very much interested in teaching students, and he used to give very good classes to fundamentals. Actually, we are very fortunate. You students are very fortunate to see one of the biggest stars of the structural engineering world in our times. So we will just pray for his soul as a silent prayer. Okay, so we will get into our discussions. Today I'll be showing you some foundation based design and detailing. Kirti will be joining us, and she will be supporting me on the discussions. So we'll be showing some file design and a footing design. Before that, I want to talk about some of the things what today I faced in the office. We were doing one project for structural, and the client asked for two options. That's one to go for steel and one to go for RCC. In the steel itself, there are two options: use the roll structure or the welded together built up sections. There were two options for that. And also there were two options in the RCC side. That is, one is the RCC and one was the pre-stressing option. And the client wanted some costs on this, and there were other options like, on the foundation side, we were also looking at whether we can use the foundation, the basement itself, as a foundation. So one option was with basement and without basement. One structure will start from ground. One structure, the basement goes little into the ground. So these are the many options we have to think about. What are the cost implications? So when the foundations is designed, whether it is advantageous to go for a basement, by which some of the loads will be transferred to the basement. So looking at the basement, what is the actual saving? The basement acts like a ship because it's a concrete like a ship. There will be loads coming, and in the basement there will be a slab at the bottom slab. This bottom slab will be able to transfer some of the loads to the foundation. Okay. So this was, an option which we can think about. And what is the biggest load in a foundation slab? Can somebody say what is the biggest load in a foundation slab? Anybody? And what is that pressure? Or what is that load per meter square? See, when you are passing out of the college, you're supposed to know all this. So you should be telling me. Suppose a load is transferred to the foundation. What is the load transferred? Can anybody say what is the load, that could be transferred to the foundation? We are actually looking into the pile raft interactions. If there is a pile and if there is a raft. So it's called pile raft interaction. So when there is a pile and a raft together, that is in a basement, you are giving a raft slab. So it becomes a pile raft case. So in a pile raft case, can anybody say what will be the percentage that is shared to the slab and what is the percentage that is shared to the pile? Okay, so even if it's a mistake, somebody can tell me. We cannot say to the pile or the raft, what is the load you should take. So we have to know that it is based on some factors. So how much load is taken by a structure means it is based on the rigidity of the structure. If there is a heavy man and if it's a skinny man taking the same load, the heavy man will deflect little and the skinny man will have more deflection. So you will not be taking that much load. So you understood, no? It's based on the rigidity. So depending on the thickness of the slab, that is one parameter, thickness of the slab, the rigidity of the slab will vary. And this is, based on the rigidity of the slab or the rigidity of the pile itself. So basically you can say it is the rigidity of the structure. So this is how the pile raft interaction happens. That means if a pile is resting on rock, the entire load will be taken by the rock only, that is the pile only. Very less load is likely to go to the pile and to the slab. In the other way, if the pile is not in rock but in soft soil, the pile will sink and the sharing will be based on the rigidity of the resistance offered to the system. So this can be actually determined by the system. Okay, so I just wanted to give you some ideas of this. So you can answer my question. What is the question? Can anybody tell me what is the question?
What are the
Question itself?
loads coming on the foundation?
Yeah, very good. Thank you. What are the load coming on the biggest load that is coming on a raft slab? So as I said it, based on the rigidity of the slab, it could be the load of the structure itself. It can be a very big load because if the slab is very thick, then lot of load is likely to go to the slab. But if it's on a pile, the column is directly loading a pile in a rock, then it is going to take the entire load. Even if you increase the slab thickness, it's not going to take much of a load. So in the regular slabs, what is the live load per meter square? You would have gone through IS 875 and all, or you may know. What is the live load per floor for a residence? Okay, I'm going to make, the entire system very interesting from now onwards. You know what I'm going to do? I've already put in the message that many of you who are, going to be interactive, who's going to participating more, will be invited to join us to do some projects. Initially, we'll give you some completed projects. So you can work on any topic of your interest in the structural side, in the geotechnical side, in the PM side. So out of the many, those who interact, those who have good marks, or those who, attends, or those who have time and interest, they will be slowly taken for our projects. So you can, practice on completed projects first under our guidelines. Then you can even work on some live projects. So actually you can work on anything that is software also, software, structural, geo, PM. Altogether, there are about 50, 60 modules you can cover different areas. I don't want you to do entire things also. You can think which is your area you are interested in, whether you want to be a project manager, whether you want to be a structural person, or if a software person, somebody working on the CAD, graphics and other things, or like geotechnical, or if you want to, do little bit geotechnical and structural, then that's also possible. You can take here and there different things. Okay. So this is a very good option. We believe, we will do it together, and there are a lot of possibilities. And many of you may suggest some very good things, because more than the old generation, the new generation is exposed to new changes in the world. So you would say, yeah, we are interested in some of these things, how we can do that, how the existing things can be improved, a lot of things. That is only one part of the job. Another thing is, today we are in discussion with a couple of big fellows in the industry, and they have, shown interest in giving us the works. So we are looking at good people who are interested to join the system so that, they can join these firms directly, or you can work with us, or, or you can, basically improve your knowledge. So there's no commitment to, do anything. You can do as you want, but you will be exposed to some firms also through us, because you will be working, if you're interested, if you have time. I don't know what is your time availability, but somebody who wants to work day and night, welcome. So we are not short of, giving you works. We can give you our works completed by us, but, already done by us also to practice, and then we can actually put you into live projects also. So, couple of the projects which is coming to us is on the different sites like project management and using the ERP for them. So I'm very happy that today one of the clients was interested in the softwares or the capacity to do a better work. Told this particular term that it is a treasure of different items. So let us enjoy this, different topics. Was the suggestion? I mean, or was the welcoming words from him? And we are very much thrilled by somebody looking at that perspective. Okay, so let us do something in the digital world, doing it together and working to an overall improvement in construction as a whole. So what I'm trying to say is, all of us should feel that many of the things what we're doing is a very good opportunity. Because if you look at the PM side, nobody gives you a project management training from the first month itself. Every project manager becomes a project manager. I've told you before, every project manager becomes a project manager by doing different things for a couple of years. Maybe the best project manager becomes a project manager only maybe after 5 or 6 years, because he needs to work on different things basically, and then only practice it. That approach is also good, but it takes some time to be a project manager. We are trying to take you through a very big journey easily in a very short time. So this is the major difference. A lot of information is there. Now we are actually doing a lot of softwares. I mean, a lot of videos on the softwares which are being uploaded to the YouTube, and will be shared in the web also. So you can see a lot of videos on different items getting updated to the YouTube. Rindu, are you there? Okay, maybe Rindu is not there. Rindu is doing that. I just wanted to ask her what is the percentage completed. Okay, anyway. So today, this is some introduction I want to give about the total things. So we will try to get some other consultants who are interested in giving classes for you, or some of the stalwarts in construction who can give you classes. Okay, that is for the future. So now let's go to the today's class. So I hope you're interested. Let's go to the foundation side. Kirti, please share your screen and take a particular, we'll just go for footing design or the pile, whichever is comfortable. Kirti, are you there?
Yes, sir, I'm here. Sir, I'll be
Okay.
sharing footing design
Yeah.
that we have done earlier.
Yeah.
Hello.
Now, this is a small work. Okay, there you can show the 3D. We have modeled the structure and the load is ready. So once it is ready, what we have done is we have actually run the model through our apps pro system, and it has created the footing design. Okay, so
Yes,
can you
sir,
show that?
Yeah.
Okay, so this was produced from the through the Arts Pro. Maybe in a couple of minutes it was produced. So it's something like this. Okay, let's look at this. You can see that this we have used a little gimmick here. Can somebody say what is the difference? Can somebody say what is that we have used here? What is something different from a footing design? Anybody? Other than footing, what do you see?
Foundation
We have
layout.
Sachina, very good. What layout?
Foundation layout.
Foundation layout is the footing. Okay, footings are under the columns. Do you see anything else? Other than footing, under the column, do you see anything else? Anybody?
Is it beam column layout?
Yeah, it's a beam column layout. Beam is there. The plinth beam is there. Every footing will be connected with the plinth beam that we have added. So we have given a T-beam also there. That's the difference. Under the footing, we have given a T-beam also. So I'll explain what is the reason behind this. The reason, we will go to the soil report. Okay, it is a G+2 structure. And yeah, let's look at the other one, other soil also.
Sir, only one door.
There is only one floor. Okay. So what happens here is, on the top, there is gravelly soil, that is, the capacity is lesser, and we couldn't, there's not much of a difference. So we may have to go for large foundation. But already the plinth beam is there. So we are trying to transfer little bit load under the T-beam. And is there any problem? Because the entire structure, we have the bricks also coming in all the walls. Okay, so because the walls are there, what will happen? You have to see what will happen if the walls are not there. If the walls are not there, the load will be transferred to the plinth beam, and that load will be transferred through the T-beams. So in that process, the T-beams will slightly bend up. Okay, so more bending moment is going to come. But if there is a brick over there, that upward tendency is balanced by the other load. Okay, that is the brick, that's the weight of the structure, is balanced through the brickwork to the other side. So the plinth beam cannot bend up. So we don't have to design the plinth beam to take large moments. So when the bricks are there, it is better to give a T-beam with just a slab, little bit slab at the bottom. You can see the section. Just show the section bigger. Okay, so this is the idea. So very little concrete extra, very little steel extra, but we are passing more load to that. So that, the economy. Today I was, asking my people the cost of a building. I told them to calculate. It was supposed to be 38 lakhs, but what they said is 36 crores. And that is not one person. For 3 or 4 people, they are, training structural people. But the problem is they don't know how to calculate the cost. So what is the definition of structural engineering or even engineering itself? Any engineer has to take an oath, like a minister or somebody who's, going to take an office. They have to take an oath that I will give. It's like doctors giving an oath. What is it called? Doctor's oath? Anybody? Okay, no problem. So we also have to give an oath, or this is a oath we have to give to the mankind, and we shouldn't do anything against it. That's the basicness by which we have to work. This is what we are saying. We will give a safe structure, plus we'll give a safe and anybody else? Can somebody say what is that? Economic, correct. So safe and economic structure. So to give it safe, we can make it safe by giving large beam, but if the beam size is more than the required, then it's not economic. It cannot be lesser, so it will not be safer. It cannot be larger, it will not be economical. So you are supposed to give the best design. So that covers the entire thing, and that is why the cost of everything is very important. Some of the cost changes when there is a war. When there is a war, Ukraine war happened, 20% of steel prices increased. So we are supposed to make a design change in the design, because steel prices have increased very much. So we have to reduce the percentage of steel that is to be used in the design. Okay, so there are certain times where steel price can go very fluctuation. So you have to actually telling the design has to be changed. Why? On a 10 crore structure, by changing the design, you can save a couple of lakhs. Okay, if it is more than your design cost, if the client is agreeing to do the design cost again, you can do that, because by changing a small thing, you will be changing very big amounts. See, one building, there are very interesting. It is very interesting area where you can be a very optimistic person, looking at every aspect of things, and actually you can a better designer will be a conjuice, will be a miser. He will not be ready to spend any material or any time unnecessarily on anything unnecessary. So he'll be spending it wisely only. He'll be looking at every opportunity to save, because only if you have a habit of looking to very high extremes, then you can become a good design engineer. There you will be looking at your physics, chemistry, and mathematics. It all matters. Because suppose a building costs 10 crores, and the slab, for example, one member, the slab thickness is 10 centimeter, and if you are unnecessarily giving 11 centimeters, the cost of 10 crore structure, because the load is also changing. Okay, so the cost of the entire structure can increase not by 10%, but say 5% extra, because load has increased. Okay, surely the live load and other things are there, which is not corresponding. So that's why I said 50%. 5% extra load is 50 lakhs. So you have to decide whether 10 centimeter or 11 centimeters to be used. So that is the interesting thing about civil engineering. In one way, civil engineering volume is there, and the mechanical engineering accuracy is also required. So when you add the mechanical engineering accuracy in civil engineering volume, there is where you require, high mathematics to compute, to, do the permutations, combinations to exactly come at very good solutions. So one structural engineer can just, do the footing design and do like that. Maybe I can do a little bit, things like this to save on the total cost of the foundation. So this is what you study. You are looking at the brick action on the plinth beam, so that there is no upward bending and there is high bending moment in that. Okay, then in the footing itself, we have given steps. So there are sloped footings are there, the stepped footings are there. Can you take the zoom on that? Bottom. Okay, you can see a step in the footing. Because the shear and the moment increases on a cantilever on the base. Now, if you look at the bottom of the slab, it is cantilevered to all the sides around the column. So it is basically the moment is WL square by 2 on a cantilever. It's a pure structure. And in the column, there is a, I am going to tell you something very interesting here. This is the base of everything. This is one of the basics of everything. That is, any structure will have the axial load on the bending stress. Every and the torsional, of course. Torsional can be changed to moment and shear. So every structure will experience the moment, shear, torsion, and axial load. So the footing is a wonderful example of all these things coming. So because of this, what happens? When all these things comes, what is the equation that we use? Anybody? To find the stresses? When you have P, when you have M, what is the equation you use? Can anybody say this? So this is, I would say, 50% civil engineering. It's not 50%, but I can say like that. Because P by A plus M by Z is the P by A means pressure by area. That's the stress due to the axial load. And due to the moment, it is, what is M by what? Can somebody say? To get the stress, the P on A, what is M by what? Can somebody say this? M by Z. Okay, section modulus. So what you ultimately get, P by A is the pressure on the soil. And if there is an mx, that's moment in one direction, it is the M by Z that is coming in the both the areas. So P by A plus mx by Z plus my by Z2, the other direction. So that will give you the stress at 4 points. So 1 point will be P by A plus M by Z plus M1 by Z, Mx by Z plus My by Z. The opposite side will be P by A minus Mx by Z1 minus My by Z. So the other things will be like this. So the combination of all these things together. So this is the basic, that is any structure. Now you know, any structure in the world, if there is P and there is M, you know how to calculate the stress on the bottom. So why I'm telling all this is, it's very fundamental. And this is the problem of our engineering education system. We are learning lot of, different structures, and then, like beam, column, footing, and all this retaining wall, all this they study by heart. They don't know actually what is happening. This P by A plus M by Z equations, it is, given as some, as a single equation to by heart for this particular case. And, people doesn't know what they learn. In actual case, so the problem is they are able to somehow do the footing, somehow able to do the retaining wall. But because you are not going through the basics, you're not able to combine a footing and a retaining wall. Nobody knows how to do when a footing combines with the retaining wall, how to do that. But there also, as you know the moment, as you know the load, as you know everything, you will be able to make your P by A plus M by Z stresses at the bottom. So once you get the stresses, you can calculate the force that is coming, that is, and the moments that is coming on the bottom slab. And you again look into different YouTube videos, different support systems where you have to understand how a thing works. So in the next classes or in the chat or in our group, you can ask these questions. So when I ask you these questions, you're not able to give the answers. You're one of the best students in the best colleges of Kerala, but we need to know these things. Otherwise, who is going to do all this in the next future? Okay. So we are supposed to understand everything what you're learning and trying to use it. Okay. So this is the basic. Okay. Yeah. Even if you're what I've talked about is basic analysis, you would have completed the basic analysis side. You wouldn't have gone. Have you completed the RCC design of slab and all in the college? RCC is completed. Hello.
Sir,
RCC design is completed now or started? Sajna?
no, no, sir.
Okay. So I'm not going to the RCC design side. What I said is the basic analysis side only. Okay. I'm not going to the design side now. To how to calculate the reinforcement and all. We will look it later. Okay. So I hope you understood something about the footing side, and I want everyone to somebody who's not familiar, who's not easy to communicate in English can talk in Malayalam. We need to communicate. We need to say. We need to make it interactive. So whatever questions, this is the time you can ask silly questions. So once somebody asks silly questions, also not a problem, because you're not supposed to answer a question with the highest level. We can ask from any level. So whatever small things, it is basically common sense. In civil engineering, one big advantage is it is all based on common sense. Okay. So anyway, now we have reached around 9 o'clock. So we will wind up for the day. The pile design, we will do it in the next class. Okay. So thank you everyone for joining. And if you have any questions, you can ask me. Otherwise, we'll conclude. Any questions? You can when I say questions, you can ask me any questions on civil engineering, your future side, or possibilities, whatever we can offer you, and any kind of things. So I'll wait for somebody to ask me. Okay, if there is no more questions, we will wind up. Thank you.
Thank you, sir.